Hello students, we're going to continue our semester review. Number 23, the amount of money you're borrowing is known as well, we did a lot of interest calculation questions this semester, and the amount of money that you're borrowing is known as the principal. The formula that we used in class to calculate compound interest, A equals P parentheses 1 plus R over N, close parentheses, raised to the n times t power. And when we did our interest rate in this formula, we always must convert the interest rate into a decimal. So as an example, if your interest rate R was 6%, what we would do is we would move the cursor. Since we have 6% is really 6.0%, we move our decimal point 2 places to the left, and our R would be 0.06. The U.S. interest rates are controlled by the Federal Reserve, and we had all of these various adverbs that we are told to calculate the interest. And interest, which is compounded 52 times per year, interest is compounded weekly. Semi-annually, our n value would be 2. Annually, our n would be 1. And continuously, we would be forced to use the second interest formula, A equals P times E raised to the R times T power. Now, as far as number 28, the value of e to the first, the way we access this on our calculator is we press the second button and then this ln, this natural logarithm button, and that gives us e raised to a power, and I just entered in first. But it's a good value to know. This exponential constant is about 2.7-ish. Now, as far as interest rates for loans, right now they're about 7%. And interest rates are always higher on loans. Banks always charge you more money to borrow than it is to save. Always cost you more to borrow. That's why it's always in your best interest financially to save. Interest that can be compounded continuously clearly is done through technology. And interest which is compounded quarterly, that would tell us our n value is equal to 4. And when solving for the interest rate, R is always a decimal value. So it's always going to be between -1 and +1. So when we're setting our viewing window, when we're solving for the interest rate R, that's always a good viewing window to use. Now let's get to some concrete mathematical examples. For problem 34, we're solving for time in our equation. We're solving for t, and the way we solve for a variable graphically is we enter one side of the equation into y1, we enter the other side of the equation, we enter that into y2, and then we look for the point of intersection. And you see the viewing window I'm about to use. Here, my y max is 35,000 because my first equation is y is equal to 30,000, and I want to choose a value bigger than 30,000. And honestly, if I'm looking at my answers, 4, 7, 12, and 15, I know my x values that I'm solving for. Now I'm solving for time, I'm solving for t, but I threw in an x in the equation. I'm actually going to change my y max to, my biggest answer is 15. I'm going to change, my x max, I'm going to change that to 20 because 20 is bigger than all of my possible answer choices. So that's what my viewing window is going to be. And now what I'm going to do is I'm going to go about finding the point of intersection of those two sides of the equation, because that's going to give me my solution. So here's my viewing window with now my x max being 20, because again, it's bigger than my answer or all my answer choices. And it looks like my point of intersection occurs when x is equal to about 7.4. So to the nearest integer, my answer is going to be letter B, or 7. So anytime we have to solve an equation in pre-calculus, we enter the left-hand side into y1, the right-hand side into y2, and then we look for points of intersection. The next set of problems deal with rational functions. And my advice for when you have to deal with rational functions, functions which are a fraction, always graph the equations and make sure that the math that you're calculating matches what it is you're looking at on the graph. So as an example for number 35, we have to find the vertical asymptote. Well, the way we find vertical asymptotes of rational functions is we set the denominator of the function equal to 0. So here my denominator is x minus 4. We solve this equation for x. So here I get x is equal to 4. I get this vertical line. And that's my answer. And according to the graph, yes, there's definitely a vertical asymptote. The graph is graphing along, then kind of dodging x is equal to 4, and then restarting after x is equal to 4. So there is a vertical asymptote when your denominator is equal to 0. And one of the things in class I told you to do for vertical asymptotes is to use your table, because for asymptotes, there's going to be an error message given to you in your table of values. And notice when x is equal to 4, there's an error. Now this is not always a foolproof plan, because sometimes your vertical asymptote can have a hole, and a point of discontinuity, would also give you an error message on your table at that value. So it's not a foolproof plan to look for errors on your table, but they kind of tell you where problems are going to occur when you're dealing with rational functions. For problem 36, we have to find the root. Remember, the roots are the same as the zeros. The roots are the x-intercepts, where the graph intersects the x-axis. And here I used my calculator to figure out that the 0 occurs at x is equal to -5. The way we find the y-intercept is we use our table of values. Recall that the y-intercept of functions always occur when x is equal to 0. So you just simply go to your table and start at 0, and here the corresponding y value is letter B, -5/4. A lot of times you'll see that written as the point 0, -5/4, but these answer choices just gave me the y value of the y-intercept. For problem 38, we have to find the horizontal asymptote. And what we do to find horizontal asymptotes is we compare the degrees of the numerator and the denominator. We look at the highest exponent of our variable. And what I did in class is I called our numerator's degree n and our denominator's degree d. So here our n value, since our numerator is x to the first power, our numerator's degree is 1. Our d, the degree of the denominator, that's also going to be 1 because it's x to the 1. Now there's 3 different things which can occur. N could be bigger than d, n could be equal to d, or n could be less than d. Since n and d are both 1, this is an example when n is equal to d. And what we do when the numerator and the denominator's degrees are the same, we set up the line y equals the lead coefficient of the numerator divided by the lead coefficient of the denominator. This is what we do to find the horizontal asymptote when n and d are the same. And in our case, n was 1 and d is 1. So here the lead coefficient of the numerator, since our numerator is 1x to the first, our lead coefficient is 1. Since our denominator is also 1x to the first, our lead coefficient of the denominator is 1. So the line y equals 1 over 1. So the line y equals 1, that's going to be our horizontal asymptote. And then finally, number 39, are there any holes in the graph? Well, holes of rational functions only occur when there's a common factor of the numerator and the denominator. Well, if you look at our function, it's x plus 5 over x minus 4. Both of those expressions can't be factored. So there's no common factor. You can't cancel these x's. I hope that your algebra experience tells you that those x's can't be canceled. But x plus 5 and x minus 4 both can't be factored. So since there's no common factor, this function does not have a hole, does not have a point of discontinuity. For problems 40 through 44, we're given a different rational function. So my advice is when you do these questions, first graph and make sure that your calculations match what it is you're looking at on the graph. So for problem 40, find the root, find the x-intercept. Well, we're looking for when the graph crosses the x-axis. So what I'm going to do is I'm going to go about calculating this zero, this root, this x-intercept. And it turns out that the zero is x is equal to 0. For us, we want to go about finding the y-intercept. Well, we know since the x-intercept is 0, the y-intercept also has to be 0. But we can always use our table. And here, when x is equal to 0, so is y. So the origin is both our root and our y-intercept. Okay, the way we find the vertical asymptotes for problem 42, recall to find vertical asymptotes, we set our denominator equal to 0 and we solve. So x squared minus 9, we're going to set that equal to 0. And I'm going to move the 9 to the opposite side. So I'm going to get x squared is equal to 9, and then I'm going to take the square root of both sides. And just recall that the square root of 9 is both positive and negative 3. So our vertical asymptotes are both x is equal to 3 and x is equal to negative 3. And I'm going to use my table just to kind of verify. Notice here my table for my y-intercept. There's the value when x is 3, there's my error. And then here's my table when x is equal to negative 3, there's also an error. Now we want to find, for number 43, any holes in the graph. Recall, the way we look for holes is if there's a common factor of our numerator and our denominator. So we're looking for a common factor. My numerator is just x. That can't be factored. But my denominator, by the difference of perfect squares, factors into x plus 3 and x minus 3. So my denominator can be factored, but there is no common factor. This x and these x's, they can't be canceled. You would need to have an x plus 3 up top or an x minus 3 up top to have a common factor. We don't have that, so the answer is letter D. There are no holes in the graph, no points of discontinuity. Both of these error messages were accounted for with our vertical asymptotes, 3 and negative 3. And then now for number 44, to find the horizontal asymptote. The way we find the horizontal asymptote is we compare the degrees of the numerator and the denominator. So here our numerator's degree, well, we have x to the first, so our n is going to be equal to 1. Here our denominator's degree, we have x to the second, so d is equal to 2. And recall the three scenarios. N is bigger than d, n is equal to d, n is less than d. Well, since our n is 1 and d is 2, n is less than d, so when that occurs, the x-axis, or the line y equals 0, is our horizontal asymptote. So when n is less than d, like this one, n is 1, d is 2, the x-axis, or the line y is equal to 0. The previous question, we did n was equal to d. That's where we set up the lead coefficient over the lead coefficient. And if n is bigger than d, there would be no horizontal asymptote. But that's why our answer to that one was answer choice B. For problems 45 through 47, this is another rational function. And this is one that you're going to have to star or highlight. Now I'm going to get to 47 first. Is h of x continuous or discontinuous? Well, I graphed this function in the standard view, and all continuous or discontinuous means is if it's continuous, you can trace the graph without lifting your pencil off the paper. And this graph has two parts. I would graph this left-hand section, then I have to lift my pencil off the paper to graph the right-hand section. Rational functions, in general, are discontinuous functions. They have multiple breaks and stops and restarts. So they are discontinuous, and that's why the answer to 47 is B. Now for 45, find the vertical asymptotes. Again, we're going to set our denominator equal to 0 and solve. So we're going to go x squared minus 2x equals 0. I'm going to factor out an x, so I have x times x minus 2 equals 0. Then I'm going to set each of those factors equal to 0. So I have x is equal to 0, and x minus 2 equals 0. So it looks like my two vertical asymptotes are 0 and 2. However, when you look at the graph, it's not 0 and 2. Yes, there is a vertical asymptote at 0, but at positive 2, this right part of the graph goes right through positive 2. So positive 2 is not going to be a vertical asymptote. This one only has one vertical asymptote at x is equal to 0. And the reason why is this. For number 46, the question's asking you, are there any holes? Are there any points of discontinuity? Well, holes occur when there's a common factor. Look at your function, x minus 2 over x squared minus 2x. We've already factored our denominator into x times x minus 2. We did that to get our vertical asymptotes. Now there's a common factor. This x minus 2 and this x minus 2 is a common factor. So the way you get your x value of the whole is you set that common factor equal to 0 and you solve. And we already did that. You have a whole at x is equal to positive 2. Now, to get the y value, you would have to take this 2 and plug it back into what's left over of the function. But this question doesn't say this. Are there any holes? Yes. There's a hole at the 2 value of x because there's no vertical asymptote there. So holes and vertical asymptotes kind of go along the same lines. Look for error messages on your table of the calculator. And here's my calculator. Notice we have error messages at 0 and 2. So those always tell you that there's a problem somewhere at those values for your function. For problem 48, we have some financial literacy questions. We have to find a 15% down payment on a house costing $510,000. So for 48, we're going to do 15% of $510,000. We're going to do on our calculator 0.15 times $510,000. So our down payment is going to be $76,500. For number 49, you pay $3,125 a month for 30 years. Find the total payback. Well, here's what we're going to do. We're going to take the $3,125. We have to multiply it by 12 because this is our monthly payment, and there's 12 months per year. And then we're going to take that and we're going to multiply it by 30 because it's a 30-year mortgage. So we're going to do 3,125 times 12 and then by 30. So it looks like your total payback is going to be this figure. $1,125,000 on the nose. $1,125,000. A lot of money over 30 years. And then finally, number 50, annual taxes, that's the key word, annual, are $3,612. Find the monthly tax bill. Well, you have to pay $3,612 every year, but it gets divided into your mortgage payment. And since you make $12 a year, you're going to take $3,612 and then divide it by 12. So when you do that on your calculator, you're going to get $301. So that's your monthly bill. If you pay that every month for 12 payments, you'll end up paying your taxes $3,612.